Hello wonderful person, this is Anton, and today we're going to discuss a topic we haven't actually talked about for quite some time: human health in outer space. And especially because of what just happened for the first time in history. This cute picture is actually showing us the first ever medical evacuation from the International Space Station. Or to be more specific, the first time ever, astronauts had to come back to Earth early because of some kind of a medical emergency. Now, because of privacy reasons, we're not going to know exactly what happened for quite some time, but based on what we know so far, everything seems to be fine. The astronauts are okay, and no one is hurt. But because of this new announcement, I decided to finally finish a project I've been working on for basically 2 years now. A project based on nearly 60 different studies from the last 2 years that explore the idea behind microgravity, or basically living in space, and human health. And specifically, what exact effects microgravity seems to cause on the human body, and what effects most astronauts experience so far, having spent living on the International Space Station for several months. And then when it comes to space exploration, we usually focus on the incredible engineering of rockets and the beauty of distant galaxies. One of the more important questions that's often ignored is, of course, what about the human body? How exactly does space, and specifically microgravity, affect us? And is space travel ever going to happen? And the thing is, I used to explore this topic quite regularly up until several years ago, and you can find some of the older videos in the description. But since then, I sort of stopped doing this and was actually saving these studies, hoping to come back to this one day. And looks like today's that day. And mostly because of, I guess, what just happened on the International Space Station. But what most of us don't realize is that living in outer space, and specifically in microgravity conditions, produces a lot of stress on our body. And there is no better example than this: the experience of Pettit, America's oldest full-time astronaut. On his 70th birthday, Pettit returned to Earth after 220 days on the International Space Station. You can see his return right here. But while in orbit, he described feeling like he was once again 30 years old. All his little aches, all his pains disappeared, and he essentially felt much younger by just being in microgravity. Yet then, after 220 days, he returned to Earth and struggled to even get up from the floor, illustrating how quickly gravity can actually reclaim its toll on the body that has adapted to weightlessness. And so space is essentially a kind of an ultimate test for human biology. And the thing is, when we usually talk about living in outer space, we're obviously talking about living inside the capsule and usually protected from radiation. And so here we're just talking about living in microgravity. And even this seems to be very stressful. Since our body evolved for billions of years in Earth's gravity, removing this crucial ingredient makes things inside of us go really wrong pretty quickly. And here I guess let's start with some of the more gory and unusual discoveries from just the last few months. Let's start with fingernails. Because did you know that a lot of astronauts end up losing their fingernails following an experience that you see right here, basically a spacewalk. And this condition is referred to as onycholysis. Here though, it's not actually caused by gravity, but instead by extreme pressure inside the spacesuit. And so when gloves are pressurized, they usually create intense pressure points on the knuckles, restricting blood flow and eventually causing the nails to detach. With research showing that depending on the glove design, some astronauts have up to a 10 times higher chance to lose their nails eventually. And so if we do launch some kind of a mission to Mars, for example, there's a pretty high chance that a lot of astronauts are going to be nailless after just a few months. But then there are also space headaches. And this is actually a more recent discovery from 2025, but turns out that nearly every astronaut so far, male and female, suffer from horrible headaches during the first week in space. For 87% of them, these headaches would recur throughout the entire mission and would actually create a lot of distress over time. And well, one of the potential reasons for this, based on this study, seems to be the increased pressure inside the skull. And that's because on Earth, gravity normally pulls the liquid inside our body downwards, but in microgravity, the liquid builds up inside the skull, with all of this eventually resulting in constant headaches that are extremely difficult to relieve. But the thing is, this buildup of liquid and the redistribution of blood in the body can actually cause something even more serious. This is one of the most serious recent discoveries that suggests it can also cause space anemia. Now on Earth, in normal Earth conditions, our body creates and destroys approximately 2 million blood cells every single second. But in space, something seems to change, and the body starts to destroy approximately 3 million per second a 54% increase, but the number of cells being created remains the same. And turns out that this destruction of cells continues for the entire mission. So basically most astronauts eventually have a lot less red blood cells in their body. But interestingly, while they're in space, this does not seem to be a problem. In weightlessness, their bodies can adapt and blood circulates normally. However, once they return to Earth, or once they basically land on, for example, Mars, almost instantly they feel exhausted and actually have trouble adjusting to Earth conditions for at least a few weeks. And that's because anemia in this case kicks in and makes daily life experience very challenging. But what's even more concerning is what's happening on the molecular level. And this is something we've actually explored previously in one of the videos in the description, based on the discoveries from the famous NASA twin study. Here, Scott Kelly was in space, and his brother was on Earth. And once Scott returned to Earth, researchers collected a lot of samples from both brothers in order to find out how their DNA changed and how their body was affected. And well, it turns out that while Scott Kelly was in space, some of the protective caps on his chromosomes, referred to as telomeres, actually lengthened. This is usually a sign of a healthy chromosome and suggests that in space his body was just a little bit healthier. But once he returned to Earth, the opposite seems to have happened. They actually shortened rapidly, leaving them even shorter than before he even started the mission. So essentially his body became weakened only after he came back to Earth. But this also applies to some other parts of DNA referred to as the dark genome. Different types of DNA segments that usually remain dormant but seem to influence DNA in ways that we still don't understand. Sometimes this is also referred to as junk DNA. And well, it turns out that in space, a lot of this dark genome seems to wake up. And it seems to affect our genes in ways we still don't really understand, but it might affect biological aging. With studies discovering that living in microgravity causes a lot of cells to remain hyperactive, resulting in functional exhaustion and accelerated aging. Moreover, this was even confirmed by studying individual stem cells in lab environments. Here, stem cells exposed to space conditions usually showed depleted energy reserves and premature aging signs. With a lot of this then connected to this junk DNA that was potentially making these cells much weaker. But luckily for us, turns out that this is a reversible damage, and most of these cells return back to normal within approximately 1 year. In essence though, this confirms that our cells and our DNA seems to act entirely different in microgravity. But we have other stuff to worry about as well. Let's talk about bones, hearts, and kidneys. And while the loss of bone and muscle structure is already well documented, normally, a typical astronaut loses approximately 1 to 2% of their bone density every single month. And that's mostly because these cells keep breaking down old bones, but the other cells that are supposed to create new bones seem to dramatically slow down their activity. But some of the recent studies also discovered that this is gender dependent. Turns out women seem to actually suffer even more. On average, women may lose muscle mass much faster, and thus may actually struggle from space travel a little bit more than men. And this also seems to affect a lot of other organs too. For example, in one of the recent experiments using bioengineered heart tissues, researchers discovered that the tissue itself was beating half as much, or actually half as strong, as the tissue on Earth. And over time this resulted in what's known as arrhythmia, with the tissue developing irregular rhythms extremely similar to a typical age-related heart disease that produces similar effects. With a recent study also discovering that even kidneys seem to be affected. And that's because the way our body starts to process salt and the way it seems to break down bones dramatically increases the chance for kidney stones. With researchers warning that a typical mission to Mars may actually result in at least some astronauts eventually developing a permanent kidney failure, with many astronauts obviously also developing kidney stones. And that's something that you probably don't want to have in outer space with no medical intervention around you. But some of the most interesting discoveries were related to the brain. And one of the most common issues that pretty much everyone experiences is now referred to as SANS, Spaceflight Associated Neuroocular Syndrome. This is something that approximately 70% of astronauts experience. And so in short, this is a major vision problem. Because of the way fluid shifts in space, the back of the eyeball can actually flatten, causing the optical nerve to swell. And as a result, astronauts start to experience a lot of vision problems that in some cases can even be described as partial blindness. But luckily for most of them, this usually corrects itself on Earth. But unluckily for some of them, this doesn't always happen. For a few of them, this was permanent. And so following several months in outer space, a person can develop a permanent vision problem. Not to mention that microgravity also shifts the brain by approximately 2.5 millimeters upwards. And depending on the person, it can produce anything from balance problems to dizziness that can actually last for weeks following the return to Earth. This is of course one of the main reasons why astronauts have trouble walking once they land. And to add to all of this, we also have to discuss something that we usually don't consider on Earth, but that can become super dangerous in space. Here we're talking about the microbiome inside of us and various microbes we're taking with us to outer space, especially on, for example, once again, a Mars mission. Because we're never really going to be traveling alone. We're taking trillions of microbes that are living in and on our bodies. And here scientists discovered that at least 13 strains of bacteria, especially Enterobacter bugadensis, unfortunately mutated into what's known as a multi-drug resistant form. Or in other words, they mutated to be superbugs. And though in normal conditions on Earth they don't generally cause problems, turns out in microgravity they can suddenly change and potentially even become deadly. And so basically for some astronauts that have certain bacteria inside of them, and by the way pretty much all of us have different microbiome depending on what we eat, may actually accidentally discover that one of those bacteria become extremely dangerous and pathogenic and start causing problems inside their body just because there is no more gravity and the bacteria changed. And this also seems to affect our food. For example, in one experiment using lettuce, researchers discovered that because of microgravity, the tiny pores inside lettuce leaves seem to stay open instead of being closed. And this unfortunately caused some of these leaves to store bacteria inside instead of releasing them as they usually do, with some of these bacteria, like for example salmonella, known to be dangerous, which means that even food that we bring with us can actually become more dangerous to eat if it's not processed correctly. And last but not least, we also had some studies on human reproduction. Not that I think anyone is going to be making babies in space yet, but I guess you never know. I think here we're really thinking like way far ahead, assuming we have some kind of a colony on Mars one day. And while we do have some, I guess, bad news and some good news. The bad news is that a lot of sperm seems to become completely disoriented in microgravity. Basically, they start to move much slower, they lose the ability to find their target, and so any kind of insemination becomes extremely challenging in microgravity conditions. But the good news is that if there is insemination, the babies seem to be healthy. And this is based on the mice study, where mouse stem cells that were kept on the International Space Station for 6 months were then used to reproduce healthy, fertile space mice back on Earth. Which basically suggests that the basic building blocks of life could survive living in microgravity on some kind of a spaceship, assuming they're protected from radiation. Okay, so quite a lot of different challenges. But before we talk about some of the potential solutions, I wanted to briefly mention some other discoveries that I didn't really get to mention much, but that still discovered something that nobody knew about before when it comes to space health. Let's do this super quickly because this video is going to be super long if I have to cover every single study. Okay, first we have dental health. Astronauts have a much higher risk for gum disease, and their jaws usually become much weaker because of bone loss. Also, astronauts that experience some kind of a concussion in the past seem to have a much higher chance of developing brain issues and especially vision loss if they then have to live in microgravity for at least a few months. On top of this, turns out that food tastes very bland in outer space as well. And this seems to be mostly because of the contextual stress, usually due to noise and confinement, and not just because of some kind of a physical change in our body. So basically here, because you're inside a box flying in space, even delicious food seems to not taste very good. With one potentially positive discovery suggesting that when it comes to arterial problems, and especially heart problems, turns out that astronauts' arteries seem to remain healthy and disease-free for at least 5 years following the mission, and even astronauts that potentially had some kind of a heart issue seem to actually get better much quicker, so there's at least some good news. But I guess the question that we need to answer is, do we have any solutions for any of these problems? So basically, if we do end up going to Mars, do astronauts just have to deal with this? Well, we have some solutions, but not for everything. For example, previous research on the immune system identified a plant compound called quercetin that surprisingly can reverse 70% of immune system changes caused by microgravity. So there's at least one potential solution that can help astronauts avoid getting sick. Then last year, a radical new project called MitoMars explored the idea of a kind of a replacement therapy where an astronaut would basically extract their own blood that contains healthy mitochondria before they leave for space, and then re-inject this blood into themselves later in order to treat, for example, radiation damage or other blood-related conditions, with a lot of other research essentially focusing on food. Because it looks like many of these problems could be solved if we actually create a perfect solution that can then improve the gut microbiome, which will help astronauts maintain healthy conditions inside their body. But pretty much most of these studies are still in their infancy, and there is really no solution for any of this yet. Which basically leaves us with, I guess, some conclusions, and most of them are not particularly positive. And so what we've discovered so far is that cardiovascular system in astronauts seems to be surprisingly resilient, and even gets better if they stay in space. However, nearly every other system in our body seems to experience the opposite. It almost always gets worse, and in some cases does not even improve after the astronaut returns to Earth. Or basically, based on all of these studies, it looks like human body is just not ready for microgravity just yet, with the only possible solution for future missions basically being developing artificial gravity. Although this is maybe something I should have mentioned in the beginning. None of the issues we've discussed today were the result of radiation. All of this was the result of microgravity. So basically, if we can create artificial gravity conditions, technically most of these problems will disappear. But a lot of this research is really important, not just for astronauts, but even for biologists right here on Earth. Because every single one of these discoveries is now teaching us so much more about human aging right here on Earth. Because spaceflight seems to be a perfect model for the idea known as accelerated aging. It essentially helps us see how human body ages and provides key ingredients for trying to stay healthy right here on our own planet, even if we never go to space. And so these studies are super important, and scientists will be using all of this data for many years to come. But on that note, at least for now, that's all I wanted to mention. There are quite a few studies I wanted to discuss in some of the future videos, and as I mentioned, we've discussed quite a few in the past, so make sure to subscribe and check out those other videos if you'd like to learn more. On that note, thank you for watching, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.